Okay, 10.1 is called power series. This chapter is a very time consuming. We're going to study all different types of series, important series in calculus. Today though, we're just going to study infinite ones. This is the first term, this is the second term, this is the third, and so on. Or you could write it using a sigma sign. A is equal to 1 to infinity sum AK. I'll show you in a few minutes. No, I'll do it right now. So back in Algebra 2, you might have had an sigma, and let's say, it doesn't have to be A, it can be whatever, like n equals 1 to 7, and the formula was 2n minus 1. So how do you write this out? All you do is you put the first number in to the n, 2 minus 1 is 1, and then you add the next term. And it goes in chronological order, whole numbers all the way up to the highest limit. This is the low limit, this is the high limit. So now the next number you plug in there is the number 2. You're going to get 3. The next number, we just plugged a 1, we just plugged a 2, now we're going to plug a 3 in there. Then a 4, then a 5, then a 6, and the last one you're going to put in there is a 7. 2 times 7 is 14, minus 1 is 13. So, all this is saying is that this series can be written out in expanded form, like this, or it can be written using sigma, which is this. Oops. Okay, another infinite series is this. You had this in Algebra 2, it's called a geometric infinite series. The sum of every infinite series, the formula is a1 over 1 minus r, but there's a stipulation. The absolute value of r must be less than 1. Okay, so I'm going to give you a bunch of examples. For example, this one. 1 plus 1/2 plus 1/4 plus ... Okay. In order to check the ratio, figure out the ratio, you take the second one and you divide it by the first one, ends up being 1/2. Is the absolute value of r less than 1? Yes. And since it is, you can find the sum. The first term is 1 over 1 minus 1/2. 1 divided by 1/2 equals 2. So if I added up all of these terms, it'll never go past 2. Like the sum of the first term is 1. The sum of the first 2 terms is 1.5. The sum of the next 3 terms is 1.75. As you can see, these numbers are getting smaller and smaller. The next one would be 1/8. If you added 1/8 to this, and then you add 1/16, and then 1 over 32, and 1 over 64. If you did 1 over 64, that is such a small number that it's not going to do anything to the sum. For example, 1 divided by 64 is 0.015625. So, what this is doing when you add these up is it's getting closer and closer and closer to 2. It'll never pass it because it keeps getting smaller and smaller and smaller. This one though, 1 plus 3 plus 9 plus 27, ... The first thing you do is you find the r, and the fastest way to find the r is to take the second one and divide it by the first one, which is 3. Is the absolute value of 3 less than 1? No, it's not. This one you can't find the sum. Do you notice that these numbers just keep getting bigger and bigger or diverging? If it's diverging, you cannot find the sum. This one up here is converging, so you can find the sum. Okay, the next part is power series. We're going to slowly work our way into power series. And there isn't much to this section at all until we get into the next section. All it's saying, there are two types of power series. If n equal to 0 to infinity and n equal to 0 to infinity, it's cn x to the nth, which is a power series. This is CO plus C1x plus C2x squared plus dot dot dot. This is centered at x equals 0. And the other power series is Cn x minus a raised to the nth power, which is CO plus C1 x minus a plus C2 x minus a squared dot dot dot. This one is centered at x equals a. All you're remembering is that this, remember, sigma can be written as an expanded series. Okay, later on in this chapter, you need to know how to find a power series by differentiation. And this is what's given to you. 1 over 1 minus x is represented by this. They're giving you this. 1 plus x squared plus x to the n plus dot dot dot. They want you to find a power series using differentiation. So all they're going to say is, so 1 over 1 minus x equals 1 plus x squared plus x to the n plus dot dot dot. And we're doing this by differentiation. So all they're saying that if you take the derivative of 1 over 1 minus x, the book doesn't even show it. But you take the derivative doing low D high minus high D low. And you take the derivative of this side, if you think about it, the derivative of 1 over 1 minus x is 1 over 1 minus x squared. I can show you that if you want, or do you believe me that the derivative is 1 over 1 minus x squared? I'm going to bring it up, which makes it a negative 1. You're going to subtract 1 and divide by a negative 1. Oh, I think that's a negative, sorry. Glad I did it. You're going to get 1 minus x. No, it is. It's a positive, sorry. Raised to the negative 2 with another negative 1 divided by, no, not divided by, I'm getting those two mixed up. You put the negative 1 out in front, 1 minus x to the negative 2 with another negative 1, it ends up being positive. So the derivative of 1 over 1 minus x is a positive 1 over 1 minus x squared. The derivative of 1 is gone, right here. The derivative of x is 1. The derivative of x squared is 2x. The derivative of the next one is 3x squared plus dot dot dot. If the original series converges, then the differentiable series also converges. Okay, so let's go back to this right here. as x is getting bigger and bigger and bigger, you know that this is converging. You can tell that it's converging. If that's converging and this equals that, the series also is converging. And if that's converging, then the theorem says that if the original is converging, its derivatives are also converging. That's all this theorem is saying, so I'm just going to write it down right here. Here's the theorem for the rest of this chapter. If f of x, which equals some sigma from n equals 0 to infinity of Cn x minus a to the n equals Co plus C1 x minus a and so on. If that converges, then the derivative also converges. So just remember that when we get into the rest of this chapter. There's another one, finding a power of integration. Very similar to this. This is what's given again. 1 over 1 plus x, and this is equal to 1 minus x plus x squared minus x cubed plus x to the fourth plus dot dot dot. And we're going to integrate from 0 to some x. Okay, do you guys remember the fundamental theorem of calculus part 1? If you integrate from 0 to x, remember you cannot use the same letter in the integration. You need to use 1 over 1 plus and just use a different letter. Can't use the same letter. Same thing on this side. We're going to integrate from 0 to x, and in place of all the x's, I'm just going to put my t's. When you integrate 1 over 1 plus t, you get a natural log of 1 plus t equals, if you integrate 1, you get t. If you integrate a negative t, you get a negative t squared over 2. If you integrate t cubed, you get t squared, you get t cubed over 3, minus t to the fourth over 4, and so on and so on and so on. And I still need to substitute the 0 and the x, and I still need to substitute the 0 and the x. So it's the natural log of 1 plus x. And when you plug the 0 in, you're just going to get the natural log of 1, which is 0, so that knocks off. So it's just the natural log of 1 plus x, and then you're just going to put x minus x squared over 2 plus x cubed over 3. The rest of that, again, when you put the 0 in, it cancels away. Same thing with integration. If the original converges, so does the integral converge. So keep that in mind for the rest of this chapter. If the original converges, you can tell right here that it's going to converge. X keeps getting bigger and bigger. It's going to get closer and closer to 0. So keep those two in mind. I'm just going to give you some parts. There isn't much to this till we get to the next part. Because part 1, they want you to compute the limit using partial sums. Compute the limit using partial sums and decide if it diverges or converges. So I'm going to give you some examples here. It goes 2, then minus 1, plus 1, minus 1, plus 1, minus 1, and so on. Okay, I never named it, but what we were doing at the beginning of the notes was called partial sums. So go back to the notes and write, I didn't use, if it's geometric, you can use this formula. If it's not geometric, you can't use the formula. Instead of doing that, you can use, this is called partial sums. It's when you just keep breaking it down. Again, the only time you can use this formula is if it's geometric. Sometimes it's not geometric. For example, like this one, I'll just fit this in here. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Obviously, it's not times, it's going up by 1, so it's arithmetic. And as you can see, arithmetic, it's definitely not converging. You keep getting bigger and bigger, it diverges. So you really can't even use the formula because it doesn't even have an R. It's got a common difference. Okay, so for part 1, all they want you to use is partial sums to decide if it's diverging or converging. So I'm just going to make a list for the first part of the assignment. I'm going to put some over here too. And by doing partial sums, I can tell if it's converging or diverging. So the sum of the first term is 2. The sum of the first 2 terms, if you added those 2 numbers up, you get 1. The sum of the first 3 terms, if you add those up, is 2. And then the next one is 1, 2, 1. And as you can see, it's not getting closer and closer and closer to one number. It keeps going back and forth, so it diverges. Number 2, 3 plus 0.5 plus 0.05 plus 0.005 plus 0.0005 plus dot dot dot. The sum of the first term is 3. The sum of the first 2 terms is 3.5. The sum of the first 3 terms is 3.55. The sum of the first 4 terms is 3.555. The sum of the first 5 terms is 3.5555. Definitely, it's not going to ever, it's converging. And it's never ever getting, it's never going to pass up the 3.5. Let me just check the ratio really quick. As you can see, it's 3.5 repeating. It converges. And if it's converging, they want you to find the sum. So the sum is 3.5. The next one, number 3, all they want you to do is to tell if it's converging or diverging. And you can use whichever method you want. So here's the beginning of the series, and what does this mean down here at the end? That's the formula. That would be the formula that you would have to put as n equals 1 to infinity. This is what would have to go right there, negative 1 to the n plus 1. What does this do? This makes it positive and negative. This keeps switching it. If you take a negative 1 and raise it to the first power, it's I guess you'd have to start with 0 here, not 1. N is equal to 0. And when you plug 0 in, you get 1, and 0 plus 1 is 1 for the first one. And then n equals 1. When you plug n equals 1 in there, you get negative 1 to the first. 1 plus 1 is 2. And that's going to make it negative. And even powers make it positive, odd numbers make it negative. So that's what that means over there. How did I do part 2 to tell if it's converges or diverges? I'm going to pause for 1 minute. Okay, so this one, I'm just going to do partial sums for this one. This is 1. The sum of this is a negative 1. The sum of this is 2. The sum of this is a negative 2. The sum of this is 3. As you can see by looking at these numbers, it's not getting closer and closer to one number. It's kind of all over the place, so it diverges. Okay, the fourth one I'm going to show you is they give you the sigma. I'm just going to get this out of the book. This is problem number 14 in the book. You're starting with n equals 0 to infinity, and they give you 2/3, and they give you 5/4 to the nth. So this is what you could do. You can expand it out like I showed you. You can plug 0 in there, and you plug 0 in for n, that makes 1, and your first term is 2/3. After you plug 0 in, you can put a 1 in there, and when you put a 1 in there, you get 2/3 times 5/4, which ends up becoming 5/6. We'll do one more. We'll put a 2 in there, which is 2/3 times 25/16, which makes 25/24, and so on. So we're deciding, again, this is the sigma form of the series, this is the expanded form, and we're going to check to see if the expanded form is convergence or divergence. I could do the sum, partial sum, but I'm not going to do the partial sum. I'm looking at this, and I can see, I can figure out that, I can figure out the r, and I can put 5/6, let me try this again, 5/6, then I'm going to divide it by 2/3, and I get r equals 1.25, but let's check it. The way to check it is, again, how did I get that? I took 5/6 and I divide it by 2/3. I'm going to make sure it's right because I'm going to take the third one and divide it by the second one. So I'm going to put in my calculator, 25 divided by 24, divided by, parentheses, 5 divided by 6, and it's also 1.25. So this is a geometric series. And can you tell, in the geometric series, in order to find the sum, the absolute value of r must be less than 1. That number is not less than 1. That number is 1.25. It's greater than 1. And it only converges and gets to a certain sum. I can't use the formula. I can't use this formula up here. This formula right here, I cannot use the a1 over 1 minus r, because my 1 is not less than 1. And it won't converge to a sum then, so it diverges. Right here. So this one diverges. So I showed you by using a formula how to figure out if it converges or diverges. I showed you how to expand a sigma notation, and I showed you how to do by partial sums.